Hi everyone, today I'm going to introduce our recent work, Vocalsound, a dataset for improving human vocal sound recognition. My name is Yuan Gong, I'm from MIT. This is a joint work with Jing Yu from Signify Research and James Glass from MIT. The dataset is freely available as this link. Recognizing human non-speech vocalization is an important task and has broad applications such as automatic sound transcription and health condition monitoring. But there's two problems with current research. First, existing dataset has relatively small number of vocal sound samples. As we can see, AudioSet, FSD50K have a large number of total samples, but they only have a limited number of vocal sound samples. And as a result, model trained with existing dataset does not perform well on vocal sound detection. For example, in our previous work, PSLA audio classification model, it doesn't perform very well on the cough and sneeze class. So what we did is we crowdsourced the recordings via Amazon Mechanical Turk, and we collect 6 vocal sounds, namely laughing, signing, coughing, throat clearing, sneezing, and sniffing from each subject. Along with the recordings, we also collect meta information, including gender, age, country, native language, and health information. Specifically for the health condition, we asked, do you have a cold, allergy, or other health-related symptoms that might affect your speech? Here is a screenshot of our data collection. We collected 3,504 hits completed by 3,365 unique subjects. There's only a small subjects completed the recording more than one time. And the data is roughly gender balanced with 55% male and 45% female. And we also have a reasonable age distribution from 18 to 80. We collect data from global, but the majority class group is the US subjects. It's important to control the data quality. To do so, we approved hits according to following criteria. First, audio lengths need to be longer than 2 seconds. Second, audio should not be transcribed as words by Google Speech. Samples can be transcribed as words are manually verified. And third, audios should match the corresponding class. We use the PSLA audio tagging model with a relatively threshold to verify this. And we also manually verify 600 samples from the dataset, with about 96% judged to be high quality recordings. Finally, we also have a clean evaluation set. That is, we pay special attention to the evaluation set and manually check one sample from each speaker and remove low quality recordings. We can listen to some of the sample.
Ching, ching.
Next, we conduct 2 baseline experiments to verify the usage of the vocal sound dataset. The first experiment we did is 6-class vocal sound classification. What we did is we trained a FisherNet-based model to classify the 6 vocal sound classes. We use a simplified version of our previous PSLA model. Overall, our baseline model achieved 90% accuracy. Interestingly, classification accuracy varies with the speak group. The performance does not solely depend on the number of training samples, though. The Vocalsound dataset can facilitate future research on reducing the machine bias on the recognition accuracy on different group of people. The second set of experiment we did is combining Vocalsound with existing dataset FSD50K for the vocal sound detection from background sound task. It is a more realistic but also more challenging task because there are some background sounds that are similar to vocal sounds and hard to classify. What we did is we trained the model with first FSD50K only, and second FSD50K plus vocal sound. And then we evaluate on the FSD50K evaluation set. We want to see that if vocal sound can lead to a performance improvement on this class of interest. And from the results, we find adding vocal sound dataset to existing dataset can significantly improve the performance. We think vocal sound is ideal for the following usage. First, building vocal sound classifier and further support future research on removing model bias on various speak groups. And second, it can be a very nice evaluation set to evaluate pre-trained models' performance on vocal sound classification. It is also ideal to be combined with existing large-scale general audio datasets to further improve the model performance. The vocal sound dataset is freely available at this link, and we also provide vocal sound classification baseline code at this link, as well as the Google Colab script. So that's all I have today. Thanks for listening.